Question 6. The diagram shows the curve with that equation, natural log equation. The point, oh, but look, it's given as x is a function of y, isn't it? That's a bit unusual. At the point P, the gradient is 4, and it's given that P is close to the point with coordinates 7.5, 12. Find dx by dy in terms of y. Well, having been given x as a function of y, then it's reasonable, I suppose, of them to ask us to find dx by dy. That just means differentiate this. Don't get puzzled by the x and y's feeling the wrong way around. This is just, well, this is function of a function, the chain rule. If you want to go into the whole substitution thing, you can do. You can say t equals y cubed plus 2y, so x equals natural log of t, and put it together. Or, I've just been doing this for lower sixth, you could do the whole big bear, little bear thing. So the big bear, the whole thing, is the natural log of something, which gives us 1 over the something, when we differentiate it. Did Harry just say something bad about it? No. And then we've got the derivative of the inside bit to multiply by. Differentiate y cubed plus 2y, and we get
3y squared plus 2.
Nicely done. And that's it. There's no tidying up to be done with that, really. There is your answer. There we go, that'll do. Part 2 said, show that the y coordinate of P satisfies that equation. Well, hang on, the y, right, the point P was the point where the gradient of the curve is 4. Now hang on, the gradient of the curve is dy by dx. So we've got to be a little bit careful about how we deal with this then. At P, dy by dx is 4. That's what the question said. But we haven't written down dy by dx yet. We've written down dx by dy. So at P, dx by dy is a quarter. It's really important to remember that we're dealing with a slightly different thing here. So at P, this expression here equals a quarter. Right. Now we do at least know where we're heading towards with this. So we've got to think, how can we play around with this? Well, we noticed the answer's got a 12y squared and an 8 on the top of it. So it's pretty clear we want to multiply by that 4 to get rid of that. So let's do that first. If we multiply both sides by 4, we've got 12y squared plus 8 up there. This is crying out to be factorised, isn't it? Y cubed plus 2y. Let's take the y out as a factor. Y squared plus 2 on the bottom. And that's now equal to 1 because we multiplied by 4. And I think we're one step away from where we wanted to be, aren't we? The answer we're looking for was y equals, multiply through by the y, and we get 12y squared plus 8 over y squared plus 2 equals y. And that's exactly where we were supposed to be heading towards. We've written it the wrong way around, but there we are. That was 3 marks. And then part 3 asks us to by first using an iterative process based on the equation in part 2, find the coordinates of P. Giving each coordinate correct to 3 decimal places. Well, this is basically to say we know that the solution to this is the coordinates of P. Y at P satisfies this equation. Turn it into an iterative process. So we want to write this as being y n plus 1 is 12yn squared plus 8 over yn squared plus 2. We always expect to be given a start value with these iterative processes. We haven't been specifically told it, but it is there in the question, isn't it? What's the start value?
12.
12, it's the y value. Or we're told that P is close to this point here. Remember, it's y that we're dealing with, so we're going to start with 12. So let y0 equal 12. I think we know how to do this now, don't we? But just in case, as a quick reminder, it's a complicated function, but we can still do it on the calculator. We start by typing 12 in and pressing equals, and that stores it as the previous answer. And then we're going to type the function in, which is 12 times the answer squared. Let's put it into as a fraction. 12 times the answer squared plus 8, and the bottom of the fraction is the answer squared plus 2. And hopefully, as long as we don't press all clear, this is all going to work nicely. Press equals once, and we get, well, I'm going to write it as a decimal because we are supposed to give our answer to 3 decimal places. So that is 11.8904. I'm going to work to more than 3 decimal places until I know I've got the answer.
Wow. We
press equals again, and we get y2 would be 11.8884. So we've certainly not settled down yet with this. y3, 11.888. And it's actually 88837, so that also rounds to 8884. At which point we're pretty sure that our answer to 3 decimal places is going to be 11.888. If you want to feel doubly sure, you can always press equals again, and again we've got actually exactly the same thing all the way on the screen as we had before, so it's converged very, very quickly. That's the y value. We also need the x value. Going right back to the start of the question, we were told that x is the natural log of y cubed plus 2y. X is the natural log of y cubed plus 2y. So now we're just going to take that number that's on the screen, or even just the 11.888 number, sub it into there, and it gives us natural log of, I'm just going to use that answer that's recorded there, .44, well actually I've got 7.4407, so to 3 decimal places I need to put down 7.441 as being my coordinates. Remember the question said find the coordinates of P, so having found Y we had to do it X as well. Alright, it was a little bit of a twist on the whole iterative formula thing, because we're not used to finding Y and then having to find X from it. There it is. Great camera work.